Hey friends, welcome back to my tutorial, C++. This is part 8, and we're going to be talking about pointers. This is a long tutorial. Pointers happens to have a lot of parts to it. So this is all the things that I intend to cover, basically an example for each, but you know what, it's just a lot of material. So here we go. We're going to look into the memory address and the size of a variable, basic pointer examples. Before I continue, we're gonna have a little quiz, and I'm gonna do the program on screen, and we're gonna do. I'll see the solution. We'll see the solution here, and I will explain how that works because it's important to know, incrementation of variables, and then we've seen already arrays and vectors and other. This is chapter 8, so or part 8. So yeah, we've seen a lot of material. So this will be a good point to do a little quiz. It's a small quiz. It's only about 10 lines or less, but it's an important quiz that we need to conquer before we continue. We're going to do an accessing array elements the traditional way, which we've seen, versus the pointer way, and then how to do the memory address of the array or the memory address of each of the elements of the array. So there's 4 ways to access the elements of an array, and we're going to look into all 4 ways of doing that. We're going to be passing pointers to functions, passing pointer of an array into a function, passing a constant array to a function, passing a constant to a variable into a constant array, dynamically allocating memory, which is very important because, when you're doing programs that require a lot of memory, it's important to be able to allocate and deallocate memory. In our examples, in our computers of today, it might not be like a big deal, but when it comes to big, huge systems, it is. And you know what, 30 years ago, we looked into every kind of memory thing we needed. But anyways, we're going to look into that. Pointers to a function, smart pointers, which is one of the coolest things of all that I like personally. And then we're going to do smart pointer arrays. So this should be a very interesting what you want to say, a good tutorial. Like I said, lots of examples. This video will be accompanying the WordPress post that I have. I have a post in WordPress, and I link both of them so people can read it or they can watch the hands-on video, which is very cool. Okay, guys, so here we are in our C Lion C++ system that I have on my Mac, and let's go ahead and get started. Through the magic of copy paste. The first example we're going to look at is our memory address and size of a variable. So I'm including IOStream using std. Here's my main program, my function. So I have 2 variables. One's int a equals 10, and I have a double of b equals 5.0. So here is I put a comment on those. And what I'm going to do here, see out the value of a is a. Obviously, this is self-explanatory. Now, the address in C++, the ampersand is how we display an address of a variable. So placing the ampersand in front of the a will give me the memory address of a. So a is located in some area in our memory, and that's what this ampersand will tell me. So ampersand a is the memory address. And then a new function built into C++ is the size of, and then we can put a variable inside. And what this does is it gives us the size of the variable. So an int has a size, a double has a size. We went through all of this, a character has a size and all that. Sometimes when designing or, when we're looking at our program, we need to make sure that we have enough memory to do our program. It's not going to die in the middle of it because we run out of memory. So we need to make those calculations. Many programs don't require that. Some do. It depends on the project. Can't tell you which ones do and don't. But most likely, the most bigger programs, the ones that have more access to more records and what have you, obviously we'll have more memory requirements. And so very straightforward. I'm going to go ahead and run this program. And here it is, the value of A. See how the value of A is, and is 10 right there, because 10, 10. The address, look at the address right here. And the variable size is 4 right there. For our double, the value is 5. This is the memory address it's located at, and the variable size is 8. So very straightforward how this works. Again, the ampersand in front of the A tells us the memory address. Size of, it's a function that tells us the size of a variable, right? So there it is. Very, very straightforward. This is one of the most basic things when it comes to pointers. Now, let's do a sample pointer example. So, okay, now this time I have A equals 10. Declare my A of int. Now here, for the first time, we introduce this little asterisk. This guy here is magic. It's the pointer. So this is how we declare a pointer. Null PTR means it's not initialized, or it's initialized to nothing. Obviously, null. The name implies it's null. But here, when I put this, the value is never used. Okay, so the first thing here I have to declare when I declare a pointer is what type of pointer is it? Is it a pointer to an int, a pointer to a double, a pointer to a float? You know, whatever type, because a pointer will hold the address of a specific thing, but it has to match. Okay, you cannot declare a pointer of type double and point it to a string or a function or a, you know, so it has to be to a double. So you need to make sure you point to the correct type of, you know, variable that you're going to point to. So int tells it it's going to be an integer pointer. The asterisk tells me that it's a pointer, and then it has not value. Now I have this comment right here. I will go over this after I run the program. Now I'm saying, look, okay, so the asterisk PTR is a pointer. PTR points to, remember, what kind of value does pointer hold? Memory addresses. That's the only thing you can point to is a memory address. And what holds the memory address of a variable? The ampersand. So pointer points to ampersand A. The memory address of A goes into the pointer. And now I say, well, the value of A is A, and the memory address is PTR. And don't worry about the comments here. I blocked all this out because I'm going to go over it. So let's run this basic program here. So it's A and the memory address, and here's the memory address where A is being held. Okay, so someone actually asked me this: what's the difference between int space PTR or int pointer, asterisk PTR? Well, believe it or not, it's the same thing. This is two different ways of doing the same thing. Some people like to do the int in an asterisk. Some people like to do int and then the asterisk PTR. I'm gonna go ahead and run this, and we should get the same thing. Okay, same thing. So it is your personal preference how you want to do it, with the asterisk after the int or before the PTR. It's up to you. Really doesn't matter. Now I'm gonna unblock this, and when I say unblock, I'm taking the comments out. The value of A, remember, this is basic stuff. Pointer PTR should be the same as A. And of course, we already been through the ampersand A is the address. So it should be, look, identical. A is 10 on both, and this is the memory address, and look at it, it's identically the same. So A, when you have a pointer, the pointer points to the memory address of A. The pointer PTR right here is the value of A. The memory address we already went through is the ampersand right here. So now what does this mean? Well, for one, because pointer PTR is the same as A, remember A is pointer PTR, I can do math. Here I'm just adding 10. Look what I'm gonna do. I'm gonna just basically add 10 to pointer PTR. Could I've done, I'm gonna put here, the same as A plus equals 10, right? It would have been the same, but I'm doing it with the pointer. So I'm gonna run it. Now, look at the memory address. The memory address never changed. I'm doing a math. I added to 10, another 10 right here, but the memory address is still the same because I'm pointing to a part of memory address and I haven't told it to not point to that. So it's gonna point to the same memory address until I tell it not to, basically. Okay, so pointer math right here. Whenever I have an asterisk and whatever the name of my pointer is, we use normally PTR because it's pointer, but it could have been anything. Okay, it could have been literally anything. I'm gonna comment this, and this, and this. Now check this out. I'm gonna do, instead of PTR, I'm gonna say A. Capital A is different than lowercase a. We've been through this. And I'm gonna do A right here. Oh, right here. Capital A, right there. Capital A points to my lowercase. So now I'm gonna do capital A here. And capital A here. This is just to prove that I'm using PTR, but I mean, I changed it to uppercase A's, which are different than lowercase A's. And I should get identically the same. I added 10 to 10 and it gives me 20 and the same memory address that I had before. So that is a basic pointer example. Before I continue, I have a small quiz. And there it is. It's a pointer quiz. And the reason I did this is because we need to make sure that we have our math correctly where it should be. What I see out here, what I'm printing out is the same as this. In fact, before I even explain this, let's run it so you can see what's happening. It's saying if int x equals 8, and int y, there's my int y, don't worry about the a, and then I'm doing int pointer PTR equals ampersand y. So I'm declaring a pointer of type int, and I'm pointing it to the memory address of y, okay? Remember, x equals a, y has no value, and my pointer is pointing to that no value. And then I'm saying, remember my pointer math, where I can do asterisk pointer plus equals 10? Well, I'm saying, look, it's equals to x plus 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 x plus 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 x plus plus. I'm doing it right here. See? What is the value of y? Now I'm gonna throw in a random value, so it's gonna say no, that's not the value. So let's do this again. This time, let's think about this for a second. What is the values of x? X is 8. So far, pointer PTR equals 8. Then afterwards, I increment. Remember, if the plus plus is after the x, I increment after something happens. If I would have done plus plus x, it would have incremented by 1 before doing the equal sign. But it's equals to 8. Now it's x equals 9 after this, PTR equals 8. Now I'm saying add it again. 8 plus 9 equals 17, and I'm incrementing this to 10 now because it's a plus plus. So PTR so far is 17, and then I'm adding it again. So this incremented to 10, here increments to 11, but before it increments right here, I'm adding it up. So the correct answer should be 27. Okay, again, 8 plus 9 plus 10, because the plus plus is after each one of the x's. So I'm adding, incrementing, adding, incrementing, adding, and it doesn't matter if I increment, I'm already having a value of y. Pointer PTR, math points to 1% of y. So the value of y is 27. So like I said, these couts here, the reason I have an A here is I'm asking the value, right? I'm asking what is the value of y, I put it into A, and I'm comparing if A equals to y, pointer PTR equals x8 plus, now it equals 9, now equals 10 plus 10. So 8 plus 9 plus 10 is 27. If A equals 27, I got it. So that's my quiz. I have this exercise on my blog, but I did not put the answer, not to trick anyone to come see the video, but I guess it helps because I can explain doing my math with a pointer, and now I'm incrementing afterwards, and afterwards, okay? The last incrementation, by the way, x at this point equals 11. In fact, I'm gonna do cout. I'm just gonna do /n. X equals, and do x. There we go. And look at the, I put a capital X here, but it doesn't matter, it's inside the quote. So let me run this. And I'm gonna do 27 because I know that's correct. See, x equals 11. Because as I said here, it increments, but before it increments, it's adding it up. 8 plus 9 plus 10, and it increments afterwards. So x equals 11, but I never added 11, I added 10. So that's a little pointer math and a little quiz. I hope you understand this, go over this video over and over. But you have to master this right here because it's a very basic thing and it's a very important thing, mostly more than anything. All right. So what if I have an array? Well, again, through the magic of copy paste, there are several ways to display array elements. We've seen this before right here. Here's my int size of 5. Here's my array. It has 5 elements, and here are the elements 1, 2, 3, 4, 5. These element numbers can change, by the way, obviously. I just chose those numbers, and it's not a constant array, so I just initialized it, basically. That's all I did. And then I have a pointer, a type int. It's not pointing to anything. It's just a pointer. Now, the traditional way to display the elements of an array is this. Between 0, 0, and the number below the size, display the element. Here's the element of the array, and then I put a couple of blank lines. But what if I want to do it with pointers? Well, now I'm pointing the IRA. PTR is now pointing to IRA. PTR is subtype int, so is my array, subtype int, so I can do that. And by default in C++, actually always in C++, when you do this, it will always point to the first element. Always to the first element. Now, that said, I'm doing the same loop here, but this time, here's my asterisk, right? Because I want to put the value. Remember, when I put asterisk in a variable, it puts the value. And I'm putting PTR plus I inside of the parentheses. And then I'm doing a tab here. So this is the traditional way. This is with the pointer. And let's see how this looks. It should get 1 through 5 and 1 through 5. See, it works. No big difference. So here's with the traditional way. Here is with the pointer. So far, so good, right? Okay, but there are more ways, obviously, to do this. Here is another way of displaying an array element. This time, we're going to be using the memory address, okay? So here's the same array, Nothing has changed from here up. Now I'm saying, here's my int pointer. And again, I use null pointer. Sometimes I use it, sometimes I don't. It is recommended that you do. In some of my examples, you'll see that I don't. Don't worry about it. When you don't do it, it's just not pointing into anything. It's just you're saying, hey, it's a pointer of type int, but I don't know where it's pointing to. This place, it's not pointing to anything. So here's my for loop again. Now this is the difference. PTR equals, and now look at this, ampersand array of I. And then I'm C out my pointer. Remember what the ampersand did? It displayed a memory address. It displayed the memory address of each element. This should, in fact, it will display my array elements. So this is the third way to do displaying of element, and I can access the elements, by the way. All I'm doing is displaying it, but if I wanted to change the value, we saw how asterisk PTR plus equals 10 will change the value, right? I can do that here. I'm not going to do it, but I could change the value of each one of the elements individually if I wanted to. But this is the other way of doing it. And there is, believe it or not, one other way of displaying the elements. Part 2, I called it. Here's my array. Here's my, the size. Here's my array with the 5 elements initialized. It's not a constant. The only constant here is the size. Here's my pointer. So far, so good. I'm pointing to the first element of my array. Now I'm saying each, display my pointer. But look, instead of doing the memory address with the ampersand, look what I'm doing. I'm incrementing my pointer. How does it know that it will point to the next element? Well, right here, int. Pointer PTR is of type int. Remember in the first example, we looked into the size of. So when you do this, it automatically knows that the size of each int is a specific number bytes, right? It's number of bytes. So when I'm incrementing my pointer, it automatically jumps to, from here to here, to here, to here, to here, and then it ends because of this condition. So this is the other way of displaying my array. So there you go, 4 ways of displaying the elements of an array. Choose the one you want, but we're looking at pointers, so I suggest you do pointers for right now for this exercise anyways. Okay, now can you pass pointers to a function? Well, of course you can. You knew I was going to say that, right? So here's my prototypes, my function prototypes. Here's get number, int, and then what we do, we put an asterisk. Remember, we used to do like in, comma, or just in, or double, or char, or string. Because it's a prototype, we're not actually putting all the variables. When it's a pointer, we put an asterisk. So get number, int asterisk, double value, int asterisk. In this example, I'm going to get a value, and then I'm going to double it. Whatever number is, I'm going to multiply times 2. So here's my main function. Here's a integer x, and I'm sending the memory address of x. Double value memory address of x. And then I'm displaying the value of x. See, I'm declaring it x. I'm printing x. What I'm sending is an address. Remember, what do pointers hold? Memory address. So if I have something of type int or double, it doesn't matter, or char or string, float, long int, you name it, doesn't matter. If I have an asterisk, I need to send an ampersand. If I have an asterisk, send an ampersand. Now let's go to the functions. And I use x also here. It could have been anything I want. So here's my function. I'm getting int, and I'm getting obviously a pointer of x. What is a number? I'm inputting the value straight into asterisk x. And on the prior example on the arrays, remember I said I can change the element of any of the elements in my array by just going into pointer functions, pointer math. Don't forget the pointer math example. It's really important because you can do whatever you do to an asterisk something, what it happens to be a pointer, you're doing it straight to the variable. I mean, that's why I emphasize that example, because you really need to know the math, your pluses, your minuses, and all that, and then know that whatever you do to an asterisk, well, any kind of pointer, you're doing it directly to the variable because it's pointing to the address of that variable. Now, on the other function, again, I'm getting an asterisk, an x, I'm getting my address, and look at this, asterisk x times equals 2. I'm basically multiplying times 2, and that's it. I don't have to return anything. These are both were type void because I'm working with the memory address. So whatever I'm doing, the memory address is over here. I'm sending the address of this. Whatever I do is doing it to the memory of it over here. I don't have to return a value, not in this case. I'm doing it straight to the memory. So how does this look? What is the number? I'm going to do 4, and the variable doubled is 8. 4 times 2 is 8. And that is how you pass a pointer to a function. This is the trick. With an asterisk, and you send an ampersand. Don't forget that. We're talking memory addresses, not regular variables. Okay, so another example here. Passing a pointer to an array to a function. Same thing, except the only difference is I'm panning. It's an array. That's all. My int pointer. I'm sorry. T array of int. This is my function prototype. My function of an array, and I'm passing a pointer. Const int items equals 5. So here's my array of items 1 through 5. The total of all array elements added is, and I'm doing my function, which is this function right here, and then end line. The program itself is pretty small. Look, so this is what, one definition of a variable of my array, one line in my return. That's a short program. But here's the main thing of this example that I want you to really understand. Here's my int pointer array. Now, the one confusion I've seen some of my students have is they think that because it's a pointer, it could be there's a difference between an array and a variable. It is in our minds. It is. An array has multiple elements, and a variable is just one variable. There's no discussion about that, undoubtedly. But what is different is that I'm using a memory address. So the moment I have a memory address, it doesn't matter. Remember what I just said in a prior example. It always points to the first element of the array. And we know the size of the array. We can calculate it. So it's very easy once we have that. Here is my array. I'm getting it over here. Now I'm saying int x equals 0 for I equals 0 less than I plus x, which is 0, 0, plus equals pointer I array plus plus. Look at this plus plus. Remember the math. Actually, as I emphasize, the pointer math is really important. I'm incrementing the size of the array in bytes, right? I'm incrementing the elements in the number of bytes for my ints. So I'm basically going through all of the elements and I'm adding it to x, and I'm returning x. This is int. I'm returning x. So I'm gonna run it, and it's gonna say 15 because 1 plus 2 plus 3 plus 4 plus 5 equals 15. So this is how you pass a pointer to an array to a function. So I'm receiving this. Now I want you to catch this. I don't know if you noticed. Remember I mentioned that if you have a pointer, you send ampersand. You send ampersand over here. But I didn't here, right? Why am I not doing that? Well, I'm only care about the first element. The rest is done in the loop. I send the first element. Remember, I'm only sending the first one, and then in the loop here I have the plus plus. Instead of having, brackets and all these things, one line does it all. I really like C++ because it's so powerful, and there's so many things you can do in so many different ways. So, okay. Now, let's see. I'm gonna do this. I'm doing copy paste for my example, so it won't take too much time. Here's part 2. In this example, you do need IO manip, okay? This is a requirement for this particular example, because I'm doing set precision, set W, fix, and show point. That's the reason I use my manip. No other reason. It has nothing to do with memory manipulation. Here's my TRA items. This example is identical to the prior example. The only difference is I'm including manipulation because I'm doing this. And we saw that in a prior part. I don't remember what part it was. Prior examples on my tutorial. Set W, set precision, fix, show point. We went through all those because I'm doing doubles. Same example. I haven't done this. Is I've not done anything different except change it from ints to doubles. So when I run the program, here's my program. See how it's nicely formatted? 101, 92, 105. They're all different lengths, by the way. And it all formatted and then gives me the total over here. So you can see how we can use IO manip. I mean, I could put $signs if it was, I can replicate a spreadsheet if I wanted to. I mean, you can see where this goes, right? I mean, but anyway, so same example as the prior one, same identical thing, except I'm using doubles instead of ints. It's the only reason I wanted to do this is so you can see that it is the same. Okay, passing a constant pointer to a function. All right. So again, void, that means PRA, which is just going to print the array values, I believe. Const int pointer, const int pointer. Constant items equals 5. Here's my const int items. What does this mean? This line right here means these values cannot change. We've been through this, right? They cannot and will not change because it is a constant. I put another array here, array 2, and this one is a regular, it's not a constant. And I put it there for a very specific reason. In fact, my example originally did not have that line, but I decided to add it because of a point that I'm about to explain. And here I just print my arrays, passing a constant array, passing a regular array. So when you have a const int pointer of an array on a function, you can send both, either a constant or a non-constant, a regular array. One's a constant, one is a regular. Either one, it will work the same. Doesn't matter. It's not that it's ignoring it, it's just you can do it. And all I'm doing here, remember the little IRA plus I, and then I'm doing the asterisk here, and I'm just displaying the elements. So what I should see is both array values. There they are, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. That's all it's doing. The whole purpose of this example is to show that I can pass the elements, even if it's constant. Now, if I have a constant, any doesn't matter what this value is. If I have a constant array, I cannot pass it to a non-constant over here. It will not work. You get an error. But if it's a constant over here, you can receive any kind of arrays. Both of these will work fine. So that's one thing that you have to be aware of. You can pass a non-constant to a constant, but not the other way around. Okay, let's go over example number 11. This is a constant pointer to a constant. So PRA const int pointer const. Now memorize this. Const int asterisk const. It's a constant int to constant, okay? I know it can get confusing. I hardly ever use these, by the way, but I do feel very strongly that I needed to mention them. I don't use them personally. I've had a need for them. Let's put it that way. I haven't had a need for them. It doesn't mean that they're, I mean, obviously they're there for a reason. And I'm pretty sure there's a lot of very, very good programmers out there that use this a lot. I have no doubt in my mind that that is the case. I just personally have not used them for the projects that I worked on. So, but it is there and I needed to cover it. So const int asterisk const. So here's my constant int array with 5 elements, which obviously means they cannot change, right? Can't change this. And then I have a const int pointer. So that cannot change either. I have a constant array, and then I have a constant int pointer that will not change. What does it mean? It means that this pointer cannot be used except once, and then that's it. You cannot, I mean, I can use it multiple times, but it will never change the value. It's gonna be set on where I set it to. And in this case is rollable, my array, right? Obviously. Then I'm gonna print my array. No big deal there. Now let's go to the actual array. Const int pointer const x, right there. Could I've done IRA here? Of course I could have. Remember when I changed that IRA to an A or a B? I can do whatever I want. Remember, this is just, this here is what I'm using inside my block. So I decided to call it X. I could have called it anything I want. And then it's just like the prior one. I'm including the elements and I'm doing the asterisk. It should print the values 1 through 5, and there they are. 1, 2, 3, 4, 5. The only difference is const int pointer const, and then my variable, right? A constant array, a constant pointer. And a constant pointer is basically a pointer that once you assign a memory address, it will not change. It will not. Because if it wasn't, if it was a regular pointer, you can point it to A, then you can point it to B, then you can point it to C, you can point it to D. And look, I'm gonna get a little bit out of topic on this point in particular, but to make my point, I'm gonna get rid of this. I'm gonna get rid of this. I'm just getting off a little topic here, but don't worry. I'm not gonna do const, I'm gonna do int pointer. And I'm gonna do int A, B, C. Actually, I'm gonna make A equals 1, B equals 2, C equals 3. And I'm gonna get rid of this line because I'm not gonna use it. Yeah, so far so good, right? I have a pointer and I have variables. Hey, I can do C out A, and B, C, and I have not used my pointer at all. I'm just going to display the values of A, B, and C and see what it does so far. There it is, 1, 2, 3, no big deal, right? Now I'm going to say PTR equals the memory address of A, and I'm going to say pointer PTR equals 10. What do you think is going to happen? What do you think is going to happen? Let's say I do PTR equals %B, pointer PTR equals 20. And then I'm going to do PTR equals %C, pointer PTR equals 30. And now I'm going to repeat this line only because I want to make sure that I have an extra line so you can see the difference. So I'm displaying the values, doing some little math here. Check this out. I got a little off topic, but look, 1, 2, 3, the same pointer, just one in PTR now equals 3 different values. See, I changed the values of the 3. You cannot do that with a const. You cannot do that. If A, B, or C were constants, I could do it. If my pointer was a constant, I would get an error. I'm not even gonna try it. I don't know how many errors I would get after that. So that's what my point was. When you have a constant, it works, that's it. You can't change it. But if it's not, the pointer, if it's a regular pointer, since I've typed int, it can point to anything it's int. If I have an array, by the way, it will work too. It will point to the first element of the array. So that's how this works. Just remember this. Okay, got a little deviated, but I felt that I was needed right there. Now, dynamically allocating memory. Back in the day, you're gonna hear this from any old programmer. You needed memory was a big problem. Memory and RAM was a big problem. Memory and hard disk was a big problem. And I remember when 20 megabyte hard drive was, well, man, we really have to be careful with our memory when it comes to records and filings, file saves, and all that. So you still have to do that, especially if you're doing a program, now, especially when we're connected through the web to everywhere in the world, and our programs can access thousands, if not millions, of records, and memory is a big deal. Okay, it is a big deal. So dynamically allocating memory means you can allocate or deallocate the memory as needed, meaning that once you don't need the memory, C++ can release that, and then it can be used for something else. This is very, very useful. I do use this, by the way. I didn't use the other one, but I do use this. So here's int pointer array, an array without elements. And here's x, and then t equals 0. How many elements in my array? I ask for x. And this is how you allocate new memory. New, this is something new. It's called new. That's just a coincidence. IArray, which is an array, equals new int with x number of elements right here. This makes a new array with that many elements, and I can do this as many times as I want to. Then I can enter the value of them. This is just a regular for loop to enter the elements into my array. And then I'm adding the values for my array here. That's just to prove what it can do. Now here's the other thing you can do. Delete the array. So the two things that you need to get from this example is new int, delete. Delete right there. New int, delete. New, allocate memory for this array. Ask how many put in elements in there. Do whatever I need to. This could have been 1,000,000, and it would ask me for 1,000,000 numbers. I don't know. I can do whatever I want, and then I can get rid of it. And by doing that, I release the memory, so I can now use that memory for something else. If I had 1,000 records, and each record was, I don't know, think about a float or a string or a long int or something. Once I'm done with all that, I can release it. You can see if I have millions of records and I kind of keep doing a lot of calculations, I can do arrays, sort them out, do this, print them, create a report, and release the memory. So it keeps my program more efficient. So new int and delete. So let's run this, and I'm gonna put 5. I'm gonna do 1, 2, 3, 4, and 5, and I add them up into 15. And by the way, if you're asking why I always use 1, 2, 3, 4, 5, it's because I don't. The screen is only so big. The last thing I want to do is enter 100 records into my example for you guys. I wouldn't put you through that terrible thing. I'm not that mean, okay? I'm actually a good guy. So new int and delete. The dynamically allocating and deleting or deallocating, all right? Okay, now let's do my next example that I have here for you guys. This is pointers to a function. This is an example. So here's int, here's my function prototype, pointer, my function int, and then I'm receiving an array, right? This here means I'm receiving an array. The function is the pointer, right? Here is a pointer to a function. So I have an array with 5 elements. I have a pointer of type int, I'm pointing to nothing, a equals 0. My pointer now points to my function right there. The pointer is to the function. So I'm saying, hey, look, since I'm now pointing this to a function for this loop, increment the values of pointer PTR plus plus, which is all, remember I'm doing the plus plus here. Remember my pointer math. I'm incrementing and I'm doing the plus equal. This here adds all the elements of the array. But what are the values of the array? Haven't done that yet. Well, now let's jump into the function. See, the pointer points to the function. So by doing this right here, I'm actually doing this. Instead of calling the function, I'm calling the pointer to the function. Here's my function. Here's my int and my array. And I'm doing a loop. I'm entering the value for each one of I, the elements of X. X is here, my array. And then I'm returning X. What am I returning? The array, right? I'm returning the array. Pointer to the function goes here. Then it goes back and I add all the elements on my array. So I'm gonna run my program. I should be able to enter 1, 2, 3, 4, 5, and I add them up to 15. So we know it works. That's a good thing. So again, the pointer is to my function. It's of type int. Here's my pointer, and that pointer points to the function. So now pointer does this. Then it comes back, and then I'm adding the values of my pointer element by element. Here's my plus plus. I'm incrementing the pointer by the total number of bytes of each int. Okay, and then I'm displaying the value. Just I'm adding into A. It's a very, very cool thing. I actually do this, use this a lot sometimes. Not too much, but I do use them. All right. Now here's what we call a smart pointer. A smart pointer means that it does it for you. We use the unique PTR, and there are more than one, by the way. I really strongly suggest that you go to my WordPress blog and read more about it. But until you do, I'm doing memory. Remember, I use IO manip for the fix and the set W and all that. Here is actually memory. This is a requirement if you want to use the unique pointer. A smart pointer, we use unique PTR. Now, this is the syntax, okay? Unique PTR. Then I tell it what type. In this case, is int. Could have been double. It could have been float. Could have been char, whatever. So unique PTR, int. And then I here have my pointer, new int. This is a dynamic pointer. This is the syntax for a smart pointer, dynamic smart pointer. Memorize it, copy it, Google it if you want. I don't care. This is a really, really cool thing because now, so I'm using the unique PTR. You need memory for this or it won't work. Type int, and here's my pointer, new int. So then I do point asterisk pointer equals 10. So what am I doing here? I'm assigning 10 to PTR, right? That's basically PTR is my variable right there. And then I'm displaying NL. So what will this do? Right there, 10. It just prints out the value. What is the cool thing about this? Once it's not used, it gets deleted automatically. This is very, very useful. Gets deleted automatically. I have one final example for you guys. And it's the same thing, but this time for an array. Smart pointers on arrays. Again, using memory, that's a requirement. Here's my size of my array. Unique PTR int, and look at the syntax right here. See, because it's an array, I got to put the brackets. And then new int, and here's the size. This line right here is a syntax for an int array, smart pointer, int array, smart pointer. And I'm just saying, look, for I equals 0, PTR of I equals I times 2. So yeah, let's see this working. And there it is, 02468. Now you're asking, where did I get that value from? I equals 0. PTR of 0 equals I times 2, right there. If I equals 0, 2 times 0 is 0. When I equals 1, 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is, right? So you see the point, right? The point of the pointer. So 0, 2, 4, 6, 8. Those are the values of this. I could have done any value. This is just showing an example. And here I'm just displaying it. This one has nothing to do with it. I guess because it's unique PTR, int an array. This is right here, a smart pointer. I hope you like this tutorial. A lot of examples, 15 examples, but there's so many things to do in pointers, and we're not done. My next tutorial, part 9, will be on C strings or strings or plus strings, everything but strings. We're gonna do more advanced strings manipulation and what have you. I hope you enjoyed this video. If you do, please like and subscribe to my channel. And also in starting with my next tutorial, I will put at the end of the video the WordPress blog where I have all this written for you guys to enjoy for free. How about that? Hope you enjoyed it. Again, like and subscribe. Thank you very much.